Unit 3, Lesson 3, Summarize, Represent, and Interpret Data on Two Variables. In this lesson, we're going to work with scatter plots, constructing lines of best fit, looking at the correlation of scatter plots, and then also discussing residuals of scatter plots. First, we're going to look at the types of correlation. If a scatter plot has positive correlation, that means as one variable increases, the other increases as well. Negative correlation, that's going to be when one variable increases, the other one is going to decrease. And then when there's no correlation, we can't recognize any pattern between the variables. As one increases, it sometimes decreases or increases. There's no set pattern in that data. Here are some examples of some scatter plots representing the different types of correlation. In the first one, we have positive correlation. As the x values increase, our y values increase as well. In the second one, negative correlation. As the x values increase, we can see that the y values are decreasing. And the last one, as our x values increase, we can't tell the pattern that's going on with the y values. Sometimes they're increasing, sometimes they're decreasing. There's no set pattern, so there's no correlation. In this first example, we want to use the data to construct a scatter plot. So one of our variables represents a given week, weeks 1 through 8, and then the other variable is going to represent the number of complaints. So if we're talking about a company, customer service, potentially, the number of complaints that that company gets that week in the customer service department. When making the scatter plot, our independent variable always goes on the x-axis, our dependent variable goes on the y-axis. Most times our independent variable, what's going to go on our x-axis, is going to be time. So when we have the number of weeks or the given week, that's time, that's going to go on our x-axis. And then we have the corresponding y-axis, which in this case is going to be the number of complaints in that week. So each of these represents an ordered pair. We need to plot all of these ordered pairs on the scatter plot. Then we're going to look and see if there's any correlation that we can see in the number of complaints. Now that all the data points are plotted, we can try to determine the correlation of the graph. As the number of weeks go along, we can see that the number of complaints are decreasing. So this would be negative correlation. As one variable increases, the other is decreasing, so we have negative correlation, which in terms of this company is a good thing. So as the number of weeks go along, they're getting fewer complaints. Their customer service department is apparently taking those complaints and making corrections. Now to the next example. What is the relationship between the independent and dependent variables in the scatter plot shown below? So as our independent variable on the x-axis, we have the hours of sleep, and the dependent variable along the y-axis is the corresponding test scores. Okay, so we can see as the number of hours of sleep increases, the test scores increase as well. So as one variable increases, the other increases. That represents positive correlation. Now we're going to take this a step further. We want to construct a line of best fit for this data. So a line that's going to go through these data points that best represents, so we can make predictions based on the number of hours of sleep you get. What is the predicted test score that you could receive? I have constructed a line of best fit for this data set. There's not necessarily one correct line of best fit. There could be a little variation in them. The general process is you want to go through at least 2 of the data points. So I went through the ordered pair 4, 77.5 and 10, 97.5. I've gone through 2 data points, and I have about as many data points above my line of best fit as I have below my line of best fit. So now what I want to do is take these 2 data points that my line goes through, these 2 ordered pairs, and I'm going to write the linear equation that goes through those 2 points, which we did earlier in the year. So I need to identify the slope and the y-intercept of that line of best fit I constructed. So to determine my line of best fit, I had to use my 2 ordered pairs, 4, 77.5 and 10, 97.5. Then I had to use my slope formula, y2 minus y1 over x2 minus x1, which simplified to 10 over 3. Once I had that, I had to plug my slope and one of the ordered pairs, doesn't matter which one I pick, into the point slope form for linear equations. So I got y minus 97.5 equal to 10/3 times the quantity x minus 10. Use the distributive property, and that got me to my next step. At this point, I had a decimal and I had fractions. We either want all of our values to be written as decimals or fractions, so I decided to get the decimal approximations for my fractions. And then the last step was to add 97.5 to the other side. So the equation I got for my line of best fit was y equals 3.3x plus 64.2. So x represents the number of hours of sleep. If I wanted to predict the score a certain student would get on the test based on the number of hours of sleep, I could plug the number of hours of sleep in for x, and that would give me the corresponding test score, y. So if a student stayed up all night, did not get any hours of sleep, this would be 0. I would predict their test score to be around a 64%. Now to the next example. This graph shows a scatter plot that relates elapsed time after taking medicine and the amount of medicine in a patient's bloodstream. So we have time on the x-axis, this could be in hours, could be in minutes. We have the amount of medicine in the bloodstream on the y-axis. And we can see the graph that represents that amount. So we want to determine which statement is true. A says the graph shows a negative nonlinear correlation. B, the graph shows no correlation. C, the graph shows a positive nonlinear correlation. D, the graph shows a negative linear correlation, or E, the graph shows a positive linear correlation. So we can eliminate a couple options because we can see this is never going to increase. As time increases, the amount of medicine appears to be decreasing pretty steadily. So anything that has a positive correlation, we can get rid of. So we can get rid of C and E. We can also get rid of B that says there's no correlation. Well, that's not true. This amount of medicine is going down at a constant percent. So we can represent or get rid of B. So now we have it narrowed down to A. The graph shows a negative nonlinear correlation. Nonlinear meaning could be a quadratic, it could be exponential. Or D, the graph shows a negative linear correlation. This type of graph should look somewhat familiar to you from the first semester when we talked about exponential equations. The amount of medicine in the system in a person's bloodstream decreases at a constant percent, representing a exponential function, which is nonlinear. It could not be choice D. We could not construct a line such that half the points are above and half the points are below. That would be some sort of direct relationship. So the best option is A. The graph shows a negative nonlinear correlation. Last thing to discuss in this lesson is what's called residuals. Residuals help determine if a curve fits a data set appropriately, whether it's accurate, whether it's the correct type of function, linear, exponential, quadratic. That's what a residual allows us to determine. It's found by taking the actual value of a data set minus the predicted value at a particular independent variable point. And then a residual plot is a scatter plot containing the original independent variable and the corresponding residuals. Okay, so I understand this is going to be confusing. This is something we'll go through more together in class. It's just simply a way to determine whether a graph we have representing our data set is appropriate. The last thing I want you to do in this lesson on your own is describe the general process for constructing a line of best fit for a scatter plot.